Hello, my name is John Oates, Wireless System Manager at Analog Devices. Today, I would like to talk to you about O-RAN, our latest open radio unit, and how we test it with Keysight's O-DU emulator and Open RAN Studio. This particular O-RU platform is a joint effort from Analog Devices, Intel, and Whizz Systems, which delivers a complete O-RAN compliant O-RU with 7.2 baseband split. The platform provides customers with a head start designing 5G radio units for the O-RAN ecosystem, easing the design burden and reducing time to market. The radio unit is comprised of two partitions, the band-agnostic small signal radio and a connectorized RF front end, designed to be easily changed for band and power variants. The small signal radio includes ADI's latest radioverse transceiver, the ADRV 9029, and our latest 7.2x Lo-Fi IP running on an Intel Area 10 FPGA. The ADRV 9029 is a 4T4R RF transceiver with two observation paths and integrated DFE functions including CFR and DPD, operating from 600 MHz to 6 GHz. The ADRV 9029 supports occupied bandwidths up to 200 MHz and transmit synthesis and observation bandwidths up to 450 MHz for DPD operation. System clocking, PTP, IEEE 1588, and synchronous Ethernet are provided by the FPGA and supported by the AD9545 clock chip. The power architecture takes advantage of the silent switcher technology included in the LTC 7150S and the LTC 3315 to ensure excellent noise and EMI performance. The RF front end supports both CBRS and C-band operation from 3.3 to 4 GHz with 5 watt plus output power per transmit channel and includes the ADRF 5515, a 20 watt dual channel receiver front end with integrated LNA and high power switches. To test the O-RAN compliance and 3GPP capabilities of our O-RU, the Keysight O-DU emulator and Open RAN Studio software is used together with Keysight signal analyzer and sources. Open RAN Studio provides O-RAN compliant control, user, and synchronization plane messaging over the eCPRI front haul, which is a fiber optic Ethernet link operating at 10 gigabits per second. 3GPP compliant 5G NR waveforms are first generated with Keysight Signal Studio Pro 5G NR. Open RAN Studio allows us to build C, U, and S-plane messages with the waveform for transmission over the downlink front haul. Various parameters can be adjusted to test the support, conformance, and interoperability of our O-RU with various O-DU vendors. Parameters such as component carriers, subcarrier spacing, antenna stream count, TDD configuration, delay management, CU plane transport, digital power scaling, beamforming, IQ compression, and S-plane are some examples of what we can adjust. The O-RAN architecture requires various synchronization needs, which include Precision Timing Protocol, PTP, and SYNC-E, which is synchronous Ethernet. The O-RUs are separated from the O-DU and OCU, so timing and phase must be aligned for TDD and FDD signals. In this demo, we test out our front haul S-plane messages by turning on IEEE 1588 V2 PTP. We've set the O-DU as PTP master, and our O-RU will receive PTP packets and process them in the timestamp unit to maintain proper synchronization. Once timing and synchronization is achieved, we can transmit over the user plane. Here, we are showing one stream, or EAXC, containing a 100 MHz 5G NR component carrier. The data rate throughput in this case is 3000 megabits per second over the front haul. Next, we turn on block floating point IQ compression and watch as the front haul data rate drops to 1800 megabits per second for the same component carrier bandwidth. Moving on to RF conformance testing, we can view the output of our O-RU in the 3.5 GHz spectrum. To maintain power efficiency while meeting spectral emissions, CFR and DPD are employed. Typical OFDM peak to average power ratio is on the order of 12 dB. Using the integrated crest factor reduction in the ADRV 9029 allows us to lower the PAPR down to 8 dB before entering the power amplifier. This allows us to operate the power amplifier in a more efficient region closer to its OP1 dB, thus saving on power. The distortion generated by operating the PA near saturation can be corrected by the integrated digital predistortion engine in the ADR-V 9029. Together, the CFR and DPD engines provide in-band flatness, spectral emissions, ACLR, and EVM improvements for the transmitter. This O-RU reference platform is just one of many from Analog Devices that cover FR1 and FR2 bands, ranging from small cells to massive MIMO configurations. Thanks for watching. For more information on any of ADI's O-RAN solutions, please visit platform.radioverse.com. And for more information on any of Keysight's O-DU emulator or Open RAN Studio, please visit keysight.com/ORAN.